Alright guys, welcome to this set of videos. These videos are going to follow along with the notes that come out of Chapter 3, Section 2 in your guys' textbook. And those notes are going to be all about, or these videos are going to be all about solving a system of inequalities by graphing. Now, before we get to the system of inequalities, actually what we're going to do is we're going to review a little bit from Chapter 1 of both this course and even in Algebra 1, where we did graph linear inequalities. So, if you need a quick refresher on graphing linear inequalities, more than what I'm going to do with you here in a second, just head on back to Chapter 1. You'll find a bunch of stuff there about an entire section on graphing linear inequalities. But for this set of notes, a couple of objectives for you, things you should be able to do by the time we get to the end of this set of videos. You need to be able to solve a system of inequalities by graphing them. Now remember, inequalities, when you graph an inequality, you are graphing a line and then shading a portion of the graph. So in order to solve a system of these inequalities, again, I'll show you this in a second, but you're going to be looking for a region of overlap, right, where the shading kind of overlaps the other shading, and that'll be our solution region, or the solution to our system. And then you're going to need to be able, and these problems are a ton of fun, you need to be able to determine the coordinates of the vertices of a region formed by inequalities. Again, I know that is a mouthful, and you're probably looking at it like, what? What we're going to do is graph a number of inequalities. They're going to form some sort of geometric shape, and you need to be able to find the vertices, the corners of that geometric shape. So let's go ahead and jump right into this. And again, what we're going to do, or what I'm going to do for you here, is just quickly review with you before we do systems of inequalities. How do you graph just an inequality? I got a bunch of reminders here for you, but really what I want to get to is this. If you were with me through Chapter 1, or if you've had a chance to go back and take a look at the section in Chapter 1 where we graphed inequalities, you would have seen this. I give you a simple four simple steps to graphing an inequality, and here it is. Step 1. What you're going to do in step 1 is you are going to replace the inequality symbol with an equal sign, and you will graph the corresponding equation. Ignore the inequality, replace it with an equal sign, graph the corresponding equation. So ignore. We will ignore the inequality and graph the corresponding equation. Yeah. So again, you'll just replace the inequality with an equal sign and graph that equation. All right, well, step 2. Once you have graphed the corresponding equation, now it's time to begin to consider that inequality. And depending on the inequality you've been given, which I talk about right here, will determine whether you draw a solid or dotted line. Again, I go over all of that with you right up here, but essentially here's the way it works. You will use a no, sorry, hang on, I apologize, that is my pen. Here's my highlighter. You will use a dashed line if you have strictly less than or strictly greater than, and you will use a solid line if you have greater than or equal to or less than or equal to, right? That's how you tell the difference between the solid or the dotted line. Okay, so let's go back to this. We've now gone through 2 of the 4 steps. So what's the next one? Well, let me slide this up a little bit here, and here we go. Step number 3. You will need to choose a test point. Yeah, choose a test point. Now, what are you generally going to use for your test point? Most of the time, in fact, every single time, you should use the point 0, 0, except when your line, right, the line that you graph, if that line goes through 0, 0, then you're going to have to pick something else. Of course, pick something easy, right? If you can't use 0, 0 because your line goes through 0, 0, if you can do 1, 1, pick that. If you can do -1, -1. Okay, great, then pick that, right? The only reason you wouldn't do 0, 0 is if your line goes through 0, 0, in which case, pick something else that's very, very easy to do math with, right? You don't have to make it complicated. Pick something easy, which is why we like 0, 0. And then finally, once you've determined the test point that works for your particular problem, step 4, based on your test point, you will then be able to determine where you shade the graph. Determine shading. Based on your test point. Okay, so here's what I'm going to do. Those are the 4 steps, right? The 4 steps that we'll use to graph inequalities. And so what I'm going to do is actually, let's take a look, right? Just to review quickly, let's take a look at how we do that with inequalities before we actually jump into the systems of inequalities. So if you head on over to the next page of the notes, I actually have a couple of example problems here, and I realize, yes, they've already been graphed, but that is just because what I want to look at is the more complicated part, of the most difficult part of the graphing inequalities is using the test point, right? That's generally what algebra students struggle with. So just real quick, since this is going to be easy to do, step 1, I'm going to graph the equation. They already did that for us. The equation that we graph is we ignore the inequality, replace it with an equal sign, solve for y. So it'll be y equals -3x plus 1, which makes perfect sense. That's why my line goes through the point 1, and my slope is -3. 1, 2, 3 over 1, right? So that's why my graph looks the way it does. Step 2 is to determine if I need a solid or dotted line. Well, because it's strictly greater than, of course that means I need a dotted 3. I choose a test point. Now, because my graph doesn't go through 0, 0, I am absolutely going to use the point 0, 0. And now we come to step 4. This is the one where generally kids get hung up. What you're going to do is you chose a test point, right? X and y. You're going to plug those values of x and y into the original problem. So I will have 3x plus y is greater than 1, which means 3 times 0 plus 0 is greater than 1, which means 0 is greater than 1. Now, based on my test point, 0, 0, do I get a true statement? Is 0 greater than 1? No, 0 is not greater than 1. That is false. So here's the way it works. Since 0, 0 was my test point, right there's 0, 0, and 0, 0 gave me a false statement, which means 0, 0 is not a solution. It's not a solution because it gave me a false statement. So that means everybody on my test point side of the line, right? If this is my line, everybody to the left is going to give you a false statement. None of these guys are going to be solutions. If 0, 0 isn't a solution, none of them will be. So what are the solutions? Well, everybody on the other side. So if your test point gives you a false statement, you shade the opposite side of the line. Whatever side your test point's on, shade the other side. If your test point gives you a true statement, that means your test point is a solution, and everybody on the test point side will be a solution. So you would shade the test point side. Let's take a look at this one just to show you how that works. Again, not difficult. Let's just run through those 4 steps real quick, right? Step 1, we graph the equation. So y equals 3 halves x plus 3, which I did. I graphed the equation for you. Well, step 2, do I need a solid or dotted line? Well, again, that depends on the inequality, and since since I am less than or equal to, the equal to means I need a solid line, which is what I gave you, a solid line. Step 3, I get to pick a test point. Since my line does not go through 0, 0, we absolutely are going to choose 0, 0. And step 4, plug it in. 0 is less than or equal to 3 halves times 0 plus 3. Remember, you are plugging your test point into the original problem and then evaluate. So I have 0 is less than or equal. 0 times 3 halves is 0, plus 3 would be 3. And the question is 0 less than or equal to 3? Yes, it is. That is a true statement. And so here's what it means. My test point is right there. My test point gave me a true statement, which means everybody on the test point side of the line is a solution. They're all going to give me true statements, which means that is the side I shade. I will shade the test point side. Since the test point is on the right-hand side of my line, I shade everybody on that right-hand side. Hopefully that helps with kind of a quick refresher on how we graphed inequalities, those 4 simple steps. So if you head on over to the next page of the notes, let's take a look at a system of inequalities. I'll meet you there.